Hello, good day everyone. We all are welcome to Halogeniusideas once more. So today we are going to be talking about algorithm and flowchart. So one of the major characteristics between humans and animals is basically intelligence, and basically intelligence has to do with how you get, you being able to think about how to get something done. So a formal way of representing how you get something done is basically what we want to talk about today: algorithm and flowchart. Without wasting much of our time, let's get right into it. So algorithm and flowchart. Um, Now, algorithm and flowchart are two different type of tools you use to explain the process of a program. And basically, a program is something you create to get something done, to solve a particular problem. That is what a program is. So, algorithm and flowchart are ways by which you can represent the processes the program is going to execute. Basically, that is what algorithm and that is one similarity between the two of them. So we are going to be talking about we are going to be defining an algorithm. We are going to be talking about the definition of a flowchart, the difference between algorithm and flowchart. Then we are going to be doing like four demonstrations, I guess. So now, an algorithm is a set of instructions for solving a problem or completing a particular task, or accomplishing rather. So one common example of algorithm is a recipe, which consists of instructions for preparing a dish or a meal. That is the closest example to most of us. So for example, if you want to cook noodles, I like noodles by the way. So if you want to get noodles done, the process is involved in you converting the raw form of noodles to the finished eatable format is what you call an algorithm. A set of instructions to get it done. So these are some examples of algorithms that we have: test for membership, arithmetic computation, payment processing, and a whole lot of other examples that we have. These are just four that are. We are going to be talking about. We are going to be doing some kind of. We are going to be representing all this using an algorithm in this video. Let's just go with me. So the flowchart, as you can see on the right, this is what a flowchart looks like. This is what it looks like. So a flowchart is the graphical or pictorial representation of an algorithm with the help of different symbols and shapes and arrows, symbol shapes and arrows to demonstrate a process or a program. Now, with algorithms, we can easily understand a program. Now, flowchart helps us to create a visual representation, a visual form of the algorithm we've written. The algorithm is in place already, but with the help of the flowchart, something we can see, a pictorial representation. That is what the flowchart is. So, as you can see, we have all these symbols. These are the symbols that are used to represent a flowchart. So this is the start or the beginning, the start. Or don't forget, before I'm very sure we understand algorithms before watching this video. An algorithm must have a starting point and an ending point. So the starting and the ending point of the algorithm, this is what you use to represent it. We have the arrows, we have the input and the output, then we have the process as well, then we have decision for control structure and all that. So now, before we go deep into doing some performing some magic, let's differentiate between algorithm and flowchart. Even though both of them are used to represent the processes of a program, they have differences. So the first difference that we're going to be talking about here: algorithm is a procedure for solving problems. Now, flowchart is a graphical representation of a process. Now, the process might as well be a process of solving a problem, but in summary, flowchart is a graphical representation of a procedure, while algorithm is the procedure itself. So the process is shown in step-by-step instructions. Step one, so. Step two, so. Then step three, so. That is how you represent an algorithm. But a flowchart, you represent it by using block by block information diagram, as you can see in the previous slide. As you can see in this slide that I have over here, you can see we have the start, the initialize x less than x naught, increment x by 1, print x, if x is less than 20, and all that. So this is a pictorial representation. Let's go back to the. So algorithms sometimes might be complex and difficult to understand. It might be complex and difficult to understand, but with the flowchart, naturally a man is moved by things he can see. So since this flowchart is something you can see, you can easily comprehend it compared to some lines of bunch of codes, algorithm, and all that. So with the help of algorithm, you can easily debug errors. You know where the errors are coming from and all that. But with the flowchart, since it's something pictorial, you're not running anything basically. So there's no way for you to check this is where the error is coming from and all that. So algorithm is showcased in natural language. Sorry about that. In natural language, English language, or whatever language is convenient for you. So English is the programmer's language. So, so the solution is showcased in pictorial format. So we are going to be doing some. We are going to be doing some examples on it, so you understand it better. Now, it is somewhat easier to solve complex problems. That is for algorithms. But flowchart, it is hard to solve complex problems. If you have a complex problem to solve, algorithm is you can easily solve those complex problems using algorithms. But flowchart, it might be for you to get the problems solved. You might have to be drawing a whole lot of control structures, decisions, input, output, and all that. So it might get your screen messed up and all that. That is one other major difference. Now the last difference is it costs more to create an algorithm. It costs more time rather to create an algorithm. But for the less time, you just map out what you want to see, what you want to get done. You just map it out. So that is. So these are the demonstrations we are going to be doing. We are going to be creating the algorithm and the flowchart to output all the values from 1 to 100, convert Celsius to Kelvin, check for winners in a debate competition, then check for membership and to process payments. We are going to be doing the algorithm and the flowchart for all this because I want you to understand. This is not rocket science, it's something you can comprehend. So let's get to it. The first one we are going to be talking about is to output all the values from 1 to 100. So let's get started. Output all the values from 1 to 100. So step 1, don't forget start. Every algorithm is going to be beginning with the start and is going to be terminating with an end. Don't forget. So step 1, start. Step 2 is to initialize a counter variable, say x to be equals to, maybe let's use 1. Initialize x equals to 1. X is going to be a counter variable. So step 3, print x, or let me say output x. Output x. Now step 4 will be to increment x. Increment x. Now step 5 if x is less than or equal to 100, back to step 3. Should we go back to step 3? So go back to step 3, then step 6, end. So for me to output all the values from 1 to 100, this is the algorithm basically. I'm going to be starting my program, then I will initialize x, a counter variable, anything like x, y, z, anything you want to use. Initialize x to 1, output your x, the current value of x, spit it out, then increment x by 1, actually, increment x by 1. So after incrementing your x by 1, you check if x is less than or equals to 100, then you go back to step 3. Go back to step 3. So then you end your program. That is it basically. That is it. So let's go to implementing the flowchart for this particular. Let me take this line out. So for me to draw the flowchart for this, I have to have I need to have my algorithm at my fingertips. So the first thing to do, the first step, which is step one, is to start the program, right? So let's go and start our program. So I'm going to be drawing the oval, then I'm going to be starting. That is my start. So then I'll draw my arrow. The step 2 is to initialize x to 1. Don't forget, this program has no input. So I'm not going to be using the input here. The next thing for me to do is a process, not an input. So the process for me to do, to execute rather, is to initialize x to 1. So come here, my x. So initialize x to 1. Now, what is the third step? Is to output x, like the current value of x, spit it out. So don't forget, my x, what do they call it again? The symbol for output here is a parallelogram. So that's what I'm going to be using exactly here. So I'm going to be drawing the line. Then I'll be having my parallelogram, don't forget. Output x. So now I'll go back to my algorithm, increment x by 1. So the current value of my x, increment it by 1. So that's the next thing I'm going to be doing. So don't forget, it is a process, not an input or output. So I'm going to be using a rectangle. So what am I supposed to do? Let me check again. I'm supposed to increment my current value of x by 1. So come here, increment. No, don't let me say increment. Let me just say x equals to x plus 1. Let me write this one separately. So x equals to x plus 1. So I'll come back here. Now, if x is less than or equals to 100, go back to step 3. So let's come back here. Now, that if you're seeing here now is a control statement. So don't forget, I'm going to be using a rectangle. No, not a rectangle. Like that kite, the diamond shaped. So come here. So I'm going to be saying is x less than or equals to 100. So I'm going to have to bring all this down. So now if yes, if you notice now, if yes, go back to step 3. That is if x is less than or equals to 100. So, and this is my step 3 over here, don't forget, output x. So I'm going to come here. So this is yes. So yes, if x is less than or equals to 100, then this is the yes. So going back to my program, the next thing for me to do is to just to say end. So there is no other thing to do. I'll come here and I'll end my program. So come here and I'll use an oval again to end my program. So this is the flowchart, the finished flowchart. This is going to look very tiny. Okay, I can't go deeper than this. So I'll try to show the algorithm and the flowchart. So this is the flowchart of the whole program. This is the flowchart. And this is the algorithm over here. This is the algorithm. So, excuse me. So that is basically algorithm and flowchart. So for the first one, we are done. Let's go to the second one. Now, the second one is telling us that we are going to be creating the algorithm and the flowchart for a program that will convert from Celsius to Kelvin. So don't forget, there is an input for this program now, and the input is the temperature in Celsius. And don't forget, for me to convert from Celsius to Kelvin, whatever is the value of my Celsius, I'm going to be having 273.15 to it to get the value in Kelvin. So that is it basically. Let's go back to the program I'm working on, convert Celsius to Kelvin. So step 1 is what? Start, don't forget, we're going to be starting. Step 2, input temperature. Now, to make it easier for me, please input T. You understand? So T will be the variable I'm using to hold the value of my temperature. So, or let me just indicate it here. Let me say key T equals to temperature in Celsius. So I can say let me say K equals to temperature in Kelvin. So that way I have two variables defined in my program already. So don't forget, the first step is to start. The second step will be to input T. The third step is a process. 3. So I can say K equals to T plus 273.15. Then step 4, output K, and step 5, end. Sorry please. So the first step is to start. The second step is to input the value of T, which is the temperature in Celsius. So the third step is to calculate the Kelvin equivalent. So it will be the temperature in Celsius plus 273.15. Then the step 4 will be for me to output the new value I've derived. Then step 5, don't forget, I will end my program. So let's go ahead to draw the flow chart for this particular program. So I don't like how this is looking. So don't forget, the first thing I'm going to be doing is to start. So I'm going to be drawing this. Now I have an input to receive from the user. So don't forget, I'm going to be using a parallelogram. So input my T. No, I don't like how my T is looking. Input my T. So now the third step is a process for me to calculate the value of my K. So let's go back here. Don't forget, that will be this. K equals to T plus 273.15. This has to. No. I have it. Okay. So what's my next step? To output the value of K, and don't forget, I'm going to be using a parallelogram. A parallelogram, yes, to output the value of K. So output K. What is the last thing to do to end my program, basically? So I'm going to be coming here. Don't forget, I'll be using the oval. And so that is it basically. So this is what the final flowchart will be looking like. So I'm going to be starting, then I will input the T, I'm going to calculate K, then I will output K, and I will end my program. That is what it will look like on the long run. So this is the algorithm for converting from Celsius to degrees, and this is the flowchart over here. This is the flowchart here. So basically that is it. Now let's go to the third one. Now to check for the winners in a debate. Sorry please, my voice is kind of. So to check for the winners in a debate, in a debate competition. Now, this algorithm, I'm going to be restricting it to just two teams. Let me say the boys team and the girls team. So it might be a debating competition. They might give you a topic, say boys are more likely to make it in life than girls, and the girls will come and tell you that. Oh, what are you saying? Girls are more likely to make it in life. So both teams came to defend and to tackle each other. Then all of a sudden we have their scores. So our program is going to be accepting those scores, and after accepting the scores, it is going to be checking which one is higher. Then the higher basically becomes the winner. The team with the higher score becomes the winner. So let's proceed to write the algorithm for this. To check for the winners in a debate competition. So let me say key. G equals to girls score, then B equals to boys score. Sorry, please. B equals to boys score. So now to start writing the algorithm, step 1 will be to start. So after starting, step 2, input G. Step 3, input B. So don't forget the step 2 here, what it's doing basically, I'm telling the user to give me the score of the girls. Then for step 3, I'm telling the users to give me the score of the boys. Don't forget, this is B here, this is B here, this is G here, and this is G here. So then I have step 4. I can say initialize, or what do I want to do? Okay. So let me do it this way. There are so many ways to do this thing, by the way. There are so many ways to do it, but I'm looking for the way that everybody will be able to comprehend. So let me say if G is greater than B, then output G. That is if the girl score is greater than the boy score. Then what if the girl score is not greater than the boy score? You know that these are two numbers that let me try to see if I can do some sort of explanation here. So if I have two numbers A and B, now mathematically speaking, the relationship between these two numbers, we have 3 possible relationships, at least 3. The first relationship that we might have is for A to be greater than B. Now another relationship that we might have is for B to be greater than A. Now the third relationship that we need to take care of is A might as well be equals to B. No, it should be A. So A might as well be equals to B. And these three scenarios, the algorithm will help us to navigate both scenarios. So let me say cut. Now, if the girl score equals to boy score, output girls score, no. G is holding a variable. Output winners, or output girls as winners. Now, step 5, I can say if boy score is greater than girl score, output boys as winners. Now, step 6. Actually, there should be an else here. Then I will have another else here. Or let me just use a comma or a semicolon here. Then else output a draw. So let me make this thing tidier. Let me make it tidier. So output girls. Let me make this thing more tidier. So output boys. So see what I have here. If the girls score is greater than the boys score, output girls. Now if boys score is greater than girls score, output boys, else output a draw. So don't forget, it's either the score of both of them are numbers. So it's either the score of the girls is greater than the score of the boys, or the score of the boys is greater than the score of the girls, or we have a draw, a tie. So step 5 basically will end the program. And that's it. So let's go ahead to draw the flow chart of this program. Let's go ahead to draw the flow chart. So don't forget, I'm going to be having my start. Then I might use the same input box to represent this step 2 and step 3, but let me do it separately. I thought it's better to do it separately, so for clarity. So input G first, okay, ladies first. So input the boys score. Now, since my step 2 and my step 3, if you look at this, my step 2 and my step 3 is completed. So let's go to step 4, which has the majority of everything we have to do. So I'll come and say if the value of girls is greater than the value of boys. You understand? So now if yes, then I want to output the value. I want to output girls as the winners. So let me say output. No. I don't know where the sound is coming from. So let me just say girls. Output girls. I want it to be able to enter this. That is if girls score is greater than boys score. So I can come here and actually I might end up modifying my algorithm. I'll check. So now, since from here now, and this is yes. So this is yes, but this is no. So if girl score is not greater than boy score, we have two possible conditions now. It's either we have a tie which is equal to, or the boy score actually is greater than the girl score. So I might have to modify the algorithm a bit, but let's draw this out. So if boy is greater than G, so now if yes, I'm going to the output boys So I'll output boys. So or I'll just say it's a tie. So don't forget. I'll output draw. So please just let me do some activity. So let me go back and modify my algorithm. So if girl score is greater than boy score, output girls. So output girls. Then it might be go to step 6 or so. But let's leave that for now. Let's leave that for now. Go to step 6. So now step 5. Now if B is greater than G, output boys, else output a draw, then end. This should be step 5. That is what it should look like. Because if you look at this, if you look at what we did here, you will notice that I have a control statement here. I have a control diagram here, somewhere here, saying that if the girl score is greater than the boy score, then if yes, just output girls. But if no, then come and check again. If boy score is greater than girl score, if yes, output boys over here. But if no, then you output a draw. But don't forget, the last step of the algorithm will be to end the program, to terminate the program. So I know that this program has 3 possible outputs. It is either for the boys to win, for the girls to win, or for you to have a tie. So let me say, after all the computations have been done, have been completed rather. So end. So end. Now I can draw this to this, this to this, and this to this, and we are done. We are done. There are so many, this particular program, there are so many ways to there are so many ways to draw the flowchart. So you can just you might decide to go with mine, but I believe this solves the problem. So sorry about that, please. Let's see what the next one is. To check for membership. Okay, for this last 2, I'm going to be doing one, then I'll leave one for you to do. So which one should I take? Check for membership or process payment? Let me take the harder one. I think the test for membership is less tedious. So let me take process payment. So for you to process payments, don't forget you are going to be getting the card details of the customer that wants to pay for something. You are going to be getting the card details of the customer that wants to pay for something. Let's assume that this particular algorithm we want to write, it is perhaps in an e-commerce website or in an online shop. So somebody decides to buy some few things, and the total price the person is supposed to pay to get those stuff, together with shipping and tax and all that, is perhaps let me say $1,500. So for me to be able to bill the person or to process payment at that point, the person will be giving me their credit card information. Then I will try to check if the current account balance of the customer is more than the total price that the person is supposed to pay. If yes, then go ahead to process the payment. If no, then decline payment, then end the program. Simple. The process payment really sounds much. It's not much actually. So it really sounds much. It's not much. So let's get to it. Let me say payment processing. So let me say I might use an object to represent the credit card details. But for now, let's just use one variable to represent the credit card details. So that's it. Let's use one variable to check the credit card details. So I can say C equals to credit card details. Then I'll come and say step 1. Don't forget, I'll start. Now step 2. Step 2. What will be my step 2? I will accept the credit card details as input. So input C, which is credit card details, don't forget. So step 3. Check the current balance of user. So let me say BAL equals to current balance of user, of customer rather. Check the current balance of the customer. So I can say BAL equals to, let me say, bank. Then see, this is becoming programmatical-ish. So how can I represent you telling the bank to, you asking the bank rather, to tell you the current account balance of the user? Let me say balance equals to, or let me say current balance of customer as provided by the bank. So don't forget, the current customer is going to be like, they will supply their credit card information as input, which is connected to their bank. So our program will be able to contact their bank, then ask their bank for their current balance. That is what this step 3 is doing basically. So step 4. Now if, let me say, T equals to total cost of selected goods. So balance equals to the current balance of the customer as provided by the bank. So I will now say if the current balance is greater than T, which is the total price, the total cost of selected goods. If it's greater than T, then accept payment. Else, decline payment. Then step 5. End. So don't forget, the step 1 is to start. Step 2 is to enter your credit card information. It might as well be your account information. So after entering the account information, our program, using the account information we've entered, we contact your bank. Your bank will tell us your current account balance. So if your current account balance is more than the total cost of selected goods you want to purchase, then we will accept the payment. Or let me say we will process the payment. Let me say process payment. Then else, if the balance you have is less than or equal to the total, most banks these days, they don't allow people to, I don't know about America, I've never been to America before, but in this part of the world, Africa, people rarely operate zero accounts anymore. I mean, banks don't allow people to operate zero accounts anymore. So even if your current balance, the total cost, even if it is the same thing, the banks will still not allow you to make that particular payment because you can't run a zero account basically. So to decline the payment, then step 5, end. So let's draw the last flow chart before we call it a day. Let's draw the last flow chart. before we call it a day. So don't forget, my flowchart is going to be start. So I'm going to be starting. Then after starting the program, the next thing I'm going to be doing is to accept the credit card details of the customer. So don't forget, that will be an input receipt, which is the credit card details of the customer. So what's the next thing? I'm going to be calculating the person's balance by contacting the person's bank to tell me the account balance, the current balance. So that is a process. No, I don't like this. So calculate the value of BAL. So from the credit card details that you are giving me, I can check your account balance. So basically, that's not how e-commerce works, by the way. But I'm just using it to explain this video. So after calculating the current balance of the person, I will now check I'll do a check here that if balance is greater than C, which is the total cost of what the person wants to purchase. Now, if yes, then proceed with the payment. Or let me say process payment. Process payment. So process payment. But if no, then you decline payment. So if yes, process payment, but if no, decline payment. So then don't forget, the last thing that we are going to be doing is to end the program. So I'll do this. So that is it basically. Don't forget, this is where the program is starting from. I wish I could show you a smaller view that calculates everything. So you have the start, you have the input C, calculate your balance, then the current customer's balance rather, then check if the balance is greater than the total cost of what the person wants to buy. If yes, process the payment, but if no, then decline the payment, then end your the whole process. So basically, that is it. So to test for membership, you should be able to do that by yourself. So that will be all about this video. Thank you for taking the time to watch the video, and it means a whole lot to us if you can take your time to share this video with your colleagues. If you can give the video a thumbs up and to drop your comment in the comment section. If you have any questions, queries, you require additional info, please use the comment section. And one last thing, if you're looking for a web designer to get you the website of your dreams, so you kindly reach out to us, and we are going to be building a very, very good website for you. So thank you very much, and I'll see you in the next video. Bye for now.